Nearly 2 kilometers of ice sit above the spot where this happened. No human has ever touched that water, and no one ever will. In 2019, engineers testing hardware for a future mission to an icy moon lowered a small robotic lander through a borehole instead of a submarine. What it filmed in the dark is still being debated today. The lander never came back up, and neither did the questions it raised. Antarctica is often described as the most studied empty place on the planet. Thousands of scientists cycling through research stations every year, running experiments on ice cores, weather, and rock samples pulled from the surface. But almost none of that research ever touches the water hidden underneath the ice itself, since reaching it takes more time, money, and risk than most projects can justify. What sits down there, in water that has been sealed off from light and air for centuries, has stayed almost completely unknown, checked only in scattered brief glimpses whenever a drilling team happens to lower a camera through a hole before it seals shut again. Every one of those glimpses lasts only a few hours at most, squeezed into a tiny window between finishing the drilling and losing the hole to the cold. There is no way to send a diver down to look around in person. No way to set up permanent cameras that could keep watching after the crew packs up and leaves. Whatever happens in that water for the rest of the year, after the hole seals shut and the team flies home, stays completely unrecorded until, if ever, another team comes back to drill nearby. For years, most polar scientists agreed on one simple rule. Life needs food, and almost every food chain on the planet starts with sunlight, hitting water or land. Under thick ice shelves, no sunlight gets through at all, so the thinking went that life should thin out fast the further you get from open water. Ice shelves in West Antarctica can stretch for well over 100 kilometers before they finally end, floating the whole way on seawater that has not felt daylight in centuries. Reaching that hidden water is not easy. A crew has to melt tons of surface, snow into hot water, then use that water to bore a narrow hole straight down through solid ice that can be a kilometer or more thick. The work often happens in weather so harsh it can shut an entire camp down overnight, and a single mistake can waste weeks of preparation. Because of all this, only a small number of these holes have ever gone deep enough to actually test what, if anything, lives in the water underneath. Most early results seem to back up the theory. Cameras lowered into these holes found a few small animals that could swim in from somewhere richer in food and swim back out again, but nothing that looked like it lived there permanently. Each quiet result made the theory feel a little more solid, and after enough of them, most researchers stopped expecting any surprises. Some polar scientists even joked that the deep water under the ice shelves was the closest thing on Earth to a dead zone, a place worth studying for its chemistry and its geology, but not for its biology. That assumption shaped how funding got handed out for years. Projects that promised to study ice cores or ocean currents got approved quickly. Projects that promised to go looking for animals in that kind of water struggled to get taken seriously at all, since reviewers assumed there was little chance of finding anything worth the expense. Textbooks from the era describe the water beneath ice shelves in passing, usually in a single paragraph, treating it as a footnote to the more interesting story of the ice above it. Students training to become polar biologists were often steered towards surface wildlife instead, penguins, seals, and seabirds that were easier to study and far more likely to produce results a university would want to publish. The deep, sealed-off water under the ice sat at the bottom of almost everyone's priority list for decades. Then, in 2019, a small international team changed that, almost by accident. The team was not looking for animals at all. They were testing a prototype lander built to one day explore the buried ocean hidden under Europa, one of Jupiter's icy moons. Before that lander could ever be trusted to fly through space, engineers needed proof that it could survive being lowered through meters of solid ice into freezing seawater and still send back clear video the whole way down. They picked a remote stretch of ice shelf in East Antarctica, far from any research station, as their practice site, since the conditions were about as close to an alien ocean as anything on Earth. Melting a hole wide enough for the lander took nearly 2 full days of nonstop work, running generators around the clock and temperatures far below freezing. The crew slept in shifts inside heated tents, while the drill ran continuously, worried that any pause would let the hole start refreezing before they were ready. Once the hole finally broke through to the seawater below, the small machine was lowered on a thin cable. Its lights and cameras switched on for the very first time in real conditions. For the first hour, the feed showed nothing but empty, dark water and a plain, muddy floor stretching out of view. A couple of engineers actually stepped away from the monitor, assuming the dive would end the way most of these dives had ended before, with nothing but silt and a wasted afternoon. Then, without warning, the lander's camera lights caught movement. Pale, thin shapes clung to a low ridge of rock on the seafloor, swaying gently even though there was no current strong enough to explain the motion. The engineers watching the feed from a tent above could not immediately tell if they were looking at animals, plant-like organisms, or something in between. Someone on the team later described the shapes as looking almost like pale fingers reaching up from the rock, moving in a rhythm that did not match anything they had studied in textbooks. Before anyone could get a clearer look or lower the lander any closer, the cable feeding it power snapped under the shifting weight of the ice above. The machine was gone, still sitting somewhere on that seafloor, its camera likely still pointed at whatever it had found. Rescue was never really an option. The borehole had already begun refreezing from the top down, and drilling a brand new hole to the exact same spot would have cost more time, fuel, and money than the whole project had left. Engineers reviewed every second of footage they still had stored, frame by frame, hoping something in the blurry recording would settle the question once and for all. It did not. Some on the team argued the pale shapes were a type of soft coral nobody had documented that far under the ice. Others thought they looked more like colonies of tube-dwelling worms, packed tightly together and swaying with water movement, too faint for any instrument to measure. A few even floated the idea that the shapes were not biological at all, just an unusual mineral formation catching the lights at a strange angle, though most of the team dismissed that explanation once they reviewed the way the shapes moved on their own. Without a physical sample, there was no way to settle the argument, and there still isn't. To this day, nobody has gone back to that patch of seafloor, and nobody has been able to confirm exactly what the lander saw in its final minutes of recording. The team did apply for follow-up funding twice in the years after, hoping to drill a second hole close enough to send another lander down for a clean, careful look. Both proposals were turned down, partly because of the cost, and partly because reviewers were not convinced a second attempt would succeed any. Better than the first, given how quickly the original hole had refrozen and swallowed the machine whole. The exact coordinates of the site are still recorded in the original mission logs, sitting untouched, waiting for a future team, with enough funding and enough patience to go back and finish what that first crew started. Some engineers who worked on the original lander have since moved on to newer prototypes, built with sturdier cables and backup power, systems specifically designed to survive the kind of sudden ice shift that ended the first mission early, treating the failure as a lesson rather than a dead end. Whether any of those newer landers ever makes it back to that same stretch of ice shelf remains to be seen, since scheduling a return mission depends on funding cycles that can take years to line up, even when the science team is eager to go back immediately. That was not the first time a machine sent into the Antarctic dark came back with more questions than answers. Nearly a decade earlier, a separate group of scientists spent years trying to reach a lake buried far deeper in the ice, sealed off from the rest of the planet for what could be over 1 million years. Getting to a lake like that means drilling through more than 3 kilometers of solid ice, without letting anything from the surface, not even a single stray germ, slip down into the ancient water below. The first attempt to reach it failed when a technical fault forced the crew to abandon the borehole just meters short of breaking through, after years of planning and a huge amount of money spent hauling fuel and equipment across the ice by tractor. Losing that much progress at the very last stretch was hard on the team, some of whom had spent the better part of a decade on the project, and had to watch the hole slowly seal itself shut again without ever reaching the water they had been chasing. A second, better-funded attempt years later finally broke through and pulled up water samples that showed faint traces of unusual chemistry, but not enough clean data to say for certain whether anything alive was living in that water or whether the strange readings simply came from contamination during the long drilling process. Even without a firm answer, missions like this matter for reasons that go far beyond Antarctica itself. 2 moons circling other planets, one around Jupiter and one around Saturn, are thought to hide entire oceans of liquid water sealed under miles of ice, kept from freezing solid by heat leaking out from deep inside those moons. Space agencies have spent years studying exactly how Antarctic teams handle these deep drilling projects, treating every mistake and every success as data for missions that have not launched yet. Every lesson learned drilling carefully into an Antarctic lake becomes a kind of rehearsal for someday reaching those distant oceans, without contaminating them the moment we arrive. If you have made it this far, you clearly like a good mystery, so go ahead and hit subscribe, since a new one drops every single week. That ancient lake is far from the only one hiding under the ice. Satellite surveys and ice-penetrating radar have since mapped several hundred separate lakes scattered beneath the Antarctic ice sheet, ranging from small pockets barely bigger than a swimming pool to vast bodies of water that rival some of the largest lakes found anywhere on the surface of the planet. Only a tiny handful of these lakes have ever actually been sampled directly, since each attempt requires its own custom drilling camp, hauled piece by piece across the ice by tractor convoys that can take weeks to reach a remote site. Life in a research camp built for this kind of work is stripped down to the basics. Tents rated for extreme cold, generators running around the clock, and supply flights that can be grounded for days at a time by sudden storms. Every one of these projects runs On a tight seasonal window, since the brief Antarctic summer is the only time flights and equipment can move safely across the ice at all, a different frozen lake, drilled using cleaner methods a few years earlier, gave researchers a far more solid answer than that ancient one ever could. In a different part of West Antarctica, a cleaner style of drilling gave scientists their clearest proof yet that something can survive down there. A joint research effort custom-built a hot water drill that filtered and treated its own water as it worked, cutting down on the outside microbes that could otherwise sneak into the borehole and contaminate everything below. The team spent months testing this drill on the surface before ever trusting it underground, running it through mock boreholes carved into surface ice just to make sure the filtering system actually worked the way the engineers hoped. When the team finally pulled up water and sediment from a shallow lake sitting under less than a kilometer of ice, the samples came back full of life. Thousands of distinct microbe types turned up, all of them living with zero sunlight and water sitting just above freezing. These microbes do not need the sun at all. They pull their energy straight from minerals dissolved in the water around them, things like iron and sulfur compounds, through a process scientists call chemosynthesis. Follow-up studies carried out over the next few years confirmed this was not a fluke or a one-time contamination event. The microbes were active and busy, breaking down organic matter and cycling nutrients through the lake in complete darkness, functioning as a real working ecosystem rather than a handful of stray cells that had simply drifted in from somewhere else. Researchers later compared samples from different parts of the same lake and found the microbe communities were not identical everywhere, hinting that different pockets of the lake might support slightly different chemistry depending on what minerals happened to be nearby. Scientists have long known about similar mineral-powered life clustered around hydrothermal vents on the open ocean floor, hot cracks in the seafloor that pump out chemical-rich water in total darkness thousands of meters below the surface. Finding a similar kind of chemistry-powered life sealed under Antarctic ice, in water that never gets anywhere near the heat of a vent, suggested that life could take hold in dark, sunless water in more than one way, using whatever chemical energy happened to be available rather than relying on any single source. Proof like that is one thing when it comes from microbes too small to see with the naked eye. It becomes something else entirely when a swimming robot films the evidence directly. In 2016, a team of engineers built a torpedo-shaped underwater robot designed to swim freely under the ice instead of staying tethered near one single spot. Building a robot that could survive that environment took years of trial and error, since ordinary underwater vehicles are not designed to squeeze through a borehole barely wider than a dinner plate and then swim for hours in water cold enough to freeze exposed skin in minutes. Its first deep run took it under a stretch of the Ameri ice shelf, hundreds of meters below the surface and far from any daylight. What its cameras recorded surprised even the researchers watching the live feed from camp. The seafloor was covered edge to edge with sea stars, sponges, and soft coral, an entire crowded community quietly thriving in permanent darkness. A few years later, the same kind of robot swam into an even harsher location, the point, where a fast-moving glacier meets the ocean in West Antarctica, an area some scientists worry could speed up rising sea levels around the world if it keeps melting the way it has been. As the robot's lights swept across the ice ceiling hanging above the seafloor, it caught sight of something nobody on the team expected. Small sea anemones had burrowed straight up into the ice itself, hanging upside down like they were growing out of the roof of a cave rather than the floor of the ocean. As the robot moved in for a closer look, each one slowly pulled itself back into its burrow, disappearing from the light one at a time, almost as if it did not want to be seen. Engineers later reviewed the footage frame by frame, trying to work out how the anemones had managed to burrow into solidus in the first place, since nothing about their bodies looked built for digging, and the question remains unresolved. The same expedition also filmed strange fish gliding upside down along the underside of the ice, using the ceiling above them the way most fish use these afloor below, resting against it and pushing off when startled by the robot's lights. Researchers had never documented that kind of upside-down behavior before, and follow-up trips have since tried, without much success, to capture clearer footage of exactly how common it is across other parts of the ice shelf. None of that needed a lake or a robot to prove Antarctica keeps secrets. Sometimes all it takes is a single iceberg breaking free. In 2021, a massive slab of ice calved away from an ice shelf on the eastern side of the continent, exposing a long stretch of seafloor that had been sealed under solid ice for years without a single ray of light reaching it. Nobody had ever been able to look at that patch of ocean floor directly before that moment. When a research vessel finally sent a camera down into the newly uncovered area, the crew found what looked like an entire nesting ground stretched out below them. Spread across the mud were hundreds of circular nests, each one guarded closely by a small ice fish standing watch over its eggs. The crew on the ship reportedly went quiet for several minutes while the footage rolled in, since nobody on board had expected to find anything more than bare, scoured seafloor left behind by the departing ice. The nests had clearly been maintained for a long time, tended patiently by parent fish living in total isolation, with no outside observer ever able to see any of it before that iceberg finally broke loose and drifted away. Researchers later noted that the nests were spaced with an almost eerie regularity, each on roughly the same distance from its neighbors, as if the fish were following some shared unspoken rule about how close they could safely build next to one another. A follow-up expedition returned to the same stretch of seafloor 2 years later to check whether the nesting ground was still active, or whether it had simply been a temporary gathering disrupted once the ice broke away. The nests were still there, still guarded, still packed with eggs, suggesting the fish had been using that patch of seafloor for generations before anyone ever knew it existed, hidden the entire time under ice that nobody had a reason to suspect was covering anything more than plain, empty mud. Marine biologists now consider it one of the densest known nurseries for that species anywhere in the Southern Ocean. There is growing pressure to protect the area from future fishing activity now that its location and importance are finally documented. One more discovery ties all of this together in a way that reaches far beyond Antarctica and even beyond biology. In 2020, a team studying the seafloor near the edge of a retreating ice shelf noticed something odd showing up on their sonar scans, a cluster of small mounds rising just slightly above the surrounding mud. Curious, they sent a towed camera sled to pass slow over the area, expecting to find nothing more than rock formations pushed up by glacial movement long ago. Instead, the footage showed pale mats of bacteria coating the mounds, along with small clusters of clams and worms clustered tightly around cracks in the seafloor where gas bubbles were visibly escaping into the water. Testing the escaping gas back at the surface confirmed it was methane, likely seeping up from ancient organic material trapped deep under the seafloor for thousands of years and only now finding a path out as the ice above retreated and pressure on the seabed shifted. Methane seeps like this are well known. In warmer oceans, where entire communities of clams, worms, and bacteria build their whole existence around the chemical energy escaping from the seafloor rather than sunlight from above. Finding one this far south, tucked directly beneath retreating polar Risa, was not something anyone on the team had planned for. It raised an uncomfortable possibility that researchers are still working through. If ancient organic carbon has been sitting trapped under Antarctic ice for thousands of years, then the ice sheets melting today are not just raising sea levels. They may also be releasing gas and carbon that has been locked away since long before recorded history. Scientists studying past extinction events have pointed to sudden releases of trapped methane as one possible trigger behind some of the fastest and most severe climate shifts in the planet's deep history, moments when global temperatures spiked in what looks, in the geological record, like the blink of an eye. Nobody is claiming Antarctica's retreating ice is about to trigger anything on that scale overnight. And the researchers who found this seep have been careful to say the connection is still speculative rather than proven. Similar methane seeps have since turned up in a couple of other spots along the Antarctic coastline, once teams started specifically looking for the telltale mounds and bubble trails on sonar scans, suggesting the first find was not a one-off fluke, but a sign of something more widespread hiding along the edges of the retreating ice. Estimating how much carbon is locked away under the entire ice sheet is still mostly guesswork, since so little of these, the floor beneath it, has ever been surveyed closely enough to spot a seep this size in the first place. But the mounds are still there, still releasing gas, and now that a retreating ice shelf has exposed them, monitoring teams return to the site whenever ship schedules allow, watching to see whether the seep grows, shrinks, or spreads to nearby cracks in the seafloor as the ice keeps pulling back year after year.